Now, moving towards the second application of machine learning, that is supervised learning. The aim is to learn a mapping from the input to an output whose correct values are provided by a supervisor. Supervised learning is divided into two parts. One is classification and the other is regression, which we will describe in the later slides. So moving forward with the classification section. In credit scoring, the bank calculates the risk given the amount of credit and the information about the customer. The information about the customer includes data we have access to and is relevant in calculating his or her financial capacity, namely income, savings, collaterals, profession, age, past financial history, and so on. The bank has a record of past loans containing such customer data and whether the loan was paid back or not. From this data of particular application, the aim is to infer a general rule coding the association between a customer's attribute and his or her risk. That is, the machine learning system fits a model to the past data to be able to calculate the risk for a new application and then decides to accept or refuse it accordingly. The slide describes an example of classification problem where there are two classes, the low risk class and the high risk class. Customers. Now, the information about a customer makes up the input to the classifier whose task is to assign the input to one of the two classes. After training with the past data, a classification rule learned may be of the form if income greater than theta 1 and savings greater than theta 2, then it's a low risk, else it is a high risk. So this is an example of discriminant. It is a function that separates the example of different classes. In the given diagram, actually it's a graph, here is the example of a training data set where each circle corresponds to one data instant with input values in the corresponding axis, where saving is in y-axis and income is in x-axis. And its sign actually indicates the classes. For simplicity, only two customer attributes, that is income and savings, are taken as the input and two classes are taken, that is low risk, which is mentioned here as a plus sign in violet color, and high risk, which is mentioned here as minus sign in red color. These are the application of classification. Moving towards number one, it helps in pattern recognition, face recognition, especially in pose, lighting, occlusion, that is glasses or beard, makeup, and of course hairstyle. It also helps in character recognition by different handwriting styles identifying, speech recognition, temporal dependency, medical recognition from symptoms to illness, in biometrics, that is recognition or authentication using physical and or behavioral characteristics, example, face, iris, signature, etc., and so on. In case of face recognition, the input is an image. The classes are people to be recognized. and the learning program should learn to associate the face images to identify. This problem is more difficult than optical character recognition because there are more classes. Input image is larger and a face is three-dimensional, as you can see here, and difference in pose and lighting cause significant changes in the image. There may be also occlusions of certain inputs. For example, glasses may hide the eyes and eyebrows, and beard may hide the chin. So basically, this were the training set of a person, and you can know that this is the person which was being represented here, and this is the test images of the person. Now, moving towards regression. Let us say we want to have a system that can predict the price of a used car. Inputs are the car's attributes, that is brand, year, engine capacity, mileage, and other information that we believe affects a car's worth. The output is the price of the car. Such problems where the output is a number are regression problems. Let's say X denote the car attributes and Y be the price of the car. Given the formula Y equals to G X by theta. G represents the model and theta represents the parameters. Again, in surveying the past transaction, we can collect the training data and the machine learning program fits a function to this data to learn y as a function of x. An example is given in this figure where the fitted function is in the form of y equals to wx plus w0 for all the suitable values of w and w0. This figure shows the model is linear and W and W0 are the parameters optimized for best fit to the training data. A training data set of used cars and the function fitted. For simplicity, mileage is taken as the only input attribute and a linear model is used. Another example of regression is navigating a car where the output is the angle by which the steering wheel should be turned at each time to advance without hitting obstacles and deviating from the route. Inputs in such cases are provided by sensors on the cars, for example, a video camera, GPS, and so on. Training data can be collected by monitoring and recording the actions of a human driver. To find the optimal setting, we fit a regression model linking these inputs and choosing new points to sample near the optimum of the current model to look for better configuration. We sample these points, check quality, add, add this to the data and fit a new model. This is generally called response surface design. These are the uses of supervised learning. Number one, in prediction of future cases, which use the rule to predict the output for future inputs. Used in knowledge extraction, but the rule is easy to understand. In compression, the rule is simpler than the data it explains. And in outlier detection, exceptions that are not covered by the rule. Example, fraud. In unsupervised learning, there is no such supervisor, and we only have to input data. The aim is to find the regularities in the input. There is a structure to the input space such that certain patterns occur more often than others, and we want to see what generally happens and what does not happen. That is by clustering, that is grouping similar instances. Here are the example of the applications. Customer segmentation in CRM. CRM full form is mentioned in the front slides. Image compression, that is color quantization, bioinformatics, learning motives. Moving towards the last application, it's the reinforcement learning. Reinforcement learning is concerned with how intelligent agent ought to take actions in an environment in order to maximize the notion of cumulative rewards. Here are the applications of reinforcement learning. Learning a policy, that is a sequence of outputs. There is no supervised output but delayed reward signal. Credit assignment problems, in-game playing, robot in a maze, multiple agents, partial observability, and so on. This slide shows about the resources of datasets that you can refer. These are the resources of journals, and this is the last slide. This is the resources of conferences that you guys can refer. Anyways, thank you.